So this problem is to use the limit definition of the derivative to find the slope of the tangent line to the curve y is equal to 3 over x at the point 7, 3 over 7. So first of all, we need to use the limit definition of the derivative. So we have the limit as h approaches 0 of f of x minus h plus, sorry, said that backwards. This should be a x plus h, and this is a minus f of x over h. Okay, so using this definition, we need to put the function with x plus h instead of x. So this will be the limit as h approaches 0 of 3 over, and instead of x, I'll put x plus h, and then minus the original function, which is 3 over x, and then all of that goes over h. So in order to evaluate this limit, we need to get this h out of the denominator. And to do that, let's start by adding our fractions on the top. In order to add fractions, we need a common denominator. So let's multiply this equation by x on top and bottom, and let's multiply this fraction by x plus h on top and bottom so we can get a common denominator. So this is the limit as h approaches 0 of 3x over, I'm going to leave the denominator not multiplied out. So this would be x times x plus h minus, I'll go ahead and multiply the numerator out, 3x plus 3h over x times x plus h. And then all of this is over h. So now that I have common denominators in my numerator fractions, I'll subtract the numerators. So this is limit as h approaches 0 of 3x minus 3x. And don't forget to distribute this minus to the other term, 3h, over the denominator stays the same, over our bottom denominator of h. Okay, so now we have a 3x and a minus 3x. So these terms can cancel, and it leaves us with the limit as h approaches 0 of negative 3h over x times x plus h all over h. So now we have a complex fraction. So let's write the denominator fraction as over 1. And then we can use the rule of if we have a fraction divided by another fraction, we flip the bottom fraction and multiply. So that makes the limit as h approaches 0 of negative 3h over x times x plus h times 1 over h. So I flipped this h over 1 to 1 over h. Now I have a factor of h on top and a factor of h on bottom. So I'm going to cancel these two out, and it gives me the limit as h approaches 0 of negative 3 over x times x plus h. So now that I have canceled out that factor of h in the denominator, now I can plug in 0 into my h, and it doesn't give me a division by 0. So I get this to be negative 3 over x times x plus 0, or just x times x, which is x squared. Whoops, that's a square. Okay, so this is my derivative, and in order to find the slope at the point 7, 3, 7, we need to plug in the 7 into our x to find the slope at this point. So the slope at this point would be negative 3 over 7 squared, which is equal to negative 3 over 49. And we can't simplify that, so that would be the final answer. So I hope this problem was helpful for you. And if it was, please subscribe to my channel and share with anybody who you think could benefit from these examples as well.